welcome to Vijay Day at Jconf. Ooh, thank you for coming and spending, well, hopefully this, it was a bit cold this morning, wasn't it?
It was a little chilly.
Cold, yeah. But, hopefully we'll warm you up with some cool talks. So this is the first one, Superman or Ironman, can anyone be a 10x developer? Anybody heard of the expression 10x developer? Woo, yes. Anybody here a 10x developer? Okay, that's cool, because that's the wrong answer. Right, okay. So you've met these guys, right? You will have met people who just seem naturally to get things done. Write more code, they fix more PRs, you name it. They just seem to naturally be able to deliver more. Yeah, we've met these guys. And though we probably shouldn't call them superheroes, quite often they get that sort of, moniker. Oh, it's these great guys, they do all this great stuff for us. They're amazing, right? So wouldn't it be good if you could be one of them? So we're going to explain just how you could be a 10x developer. And you'll be surprised, I hope, to see that the answer is not that you go and do it yourself, but actually you do it as a team. But we'll get there. Right. So who would like to write 10 times more lines of code? Really? Yeah, one or two. Okay. Who wants to fix 10 times more bugs? Yeah, who wants to work 800 hours a week?
Don't we already?
Don't we already? Yeah. But that's what we're trying to show you, how you can achieve the productivity without having to actually do these things. Because fixing 10 times bugs is not actually what you want to do. You want to have the normal amount of bugs or less bugs. That makes more sense, more productivity. Right? We don't want you to have these things. We don't want you to have a secret identity, be like any Superman who does things alone, because that's the wrong answer. And you've probably seen people who say things like this. I wrote the thing overnight, as if it's a magic trick, as if this is the really good thing to do. So that's not right either. Right? Right, so I've been around, I say a bit, more than a bit, several bytes, right? This is me. My name is Steve Poole. I work for Sonatype, hence the moniker. I care about Java, I care about security. I've been doing JVMs and Java and APIs and, been in Apache Foundation, the Clip Foundation, all these places, right? Great. So I have a big background in this space. And I have met hardly any of these guys. Hardly have I ever met a 10x developer. I've met a few, and not all of them were developers. Right? None of them were superheroes. They didn't do things on their own. They were just very good at helping us all be productive. Right? And they were all professionals. So when I talk about 10x developers, what I really mean is, how do we help everybody become more professional, more productive? We're going to interchange, I think, 10x developers and professionals, but you get the sense. It isn't about being a superhero. It's about what can you do to be more of a professional. Right? And it does take time. You cannot become an expert, a professional, without investing time and effort. Right? And you have to pick the right role models. You do not want, over and over again, you do not want this apparent superhero behavior, because that takes you down the wrong place. Right? This is the role model you want. How do you learn to be future me? How do you learn to deal with the mistakes that you're going to create? Right? They're the role models. Who helps you get there? So a 10x developer, these professional developers, are much more like Duke on a hoverboard than some mighty hero tackling 10 times the bugs that everybody else is. Much more like Ironman. Because an Ironman, if you think about Ironman in the movies, what's it about? It's about taking the skills you have, the knowledge, the experience, the brains, and applying them in new ways to achieve something that other people find that comes naturally. And as we said, there aren't that many of these superheroes. So 10x developers look more like this, right? They deliver high quality value, but only do what is necessary. And they understand that the code they write, thanks, Justin.
That's my fault.
The code, yes. The code they write, and I can't, this is like one of the superpowers that you should gain is to understand the code you write is the means to the end, right? It's the success of others that's important. Don't get head up. Don't put your ego into the code. It's not the right thing to do.
They were fishing, so I thought cod. It looked right.
Yeah, good save. Yeah. And the last thing there is understanding that it's all about a team sport, right? It is about helping everybody else be successful in your team, right? 10x developers don't say stupid things like this, right? They don't go, I thought I was using the tool correctly. No, they're much more thoughtful and considered and rational about their actions, right? You will never get professional developers saying this. And if you are a professional developer, or you consider yourself a professional developer, have a think about the times you've used a tool where you didn't know actually what it was supposed to do and you just Stack Overflowed it, right? Right. So actually, we want to show you that 10x engineers are craftspeople, people who care about the process and invest their skills in the right way. And the challenge is going to be, where is the best place to invest your skills? 10x developers are productive because they have clarity. They think about what they're trying to achieve. They just do one thing at a time. They do the right thing, right? It's the right code, it's fix bugs, it's learn new skill, but it's focused on the objectives, right? Small wins, because that moves the needle forward. Every time you do something big, you run the risk of things not going the way that you expect, right? And 10x developers succeed because they are able to take the risks that needs to happen because they're prepared. They've already got the things that they need, the test suites, the understanding of the tools. They've reduced the uncertainty, right? Because that's the way forward, right? Right, now this is a really hard skill to master. I've been doing Java development and C code development for 30 odd years. And I still get the manual out and read things and say, how does it work? Because we all do. We learn things, right? Right? But the most amazing thing is it turns out that actually this is more than just a skill. And what this man is going to explain to you is just how actually we can all be the 10x developers, because actually there's a science behind all of the things that I've just touched on. How you do these things, how you think about it, how you focus. So with that, I think I will hand over to Justin.
Thank you, Steve. Thanks, everybody. In case we haven't met before, I'm Justin Reock. I'm the Field CTO Chief Evangelist at Gradle. My background is primarily in software development. Spent a long part of my career writing code, and then moved into enterprise architecture, systems integration with a big focus on open source. And now I talk mostly about developer productivity. I think the consciousness of the industry is really shifting towards this. In fact, I'm not sure if you saw the most recent 2022 Gartner CEO report that came out, but for the first time ever, CEOs have actually converged on developer experience as one of the most important things that they're thinking about. And I think that's great. I think it's a long time overdue. So we're going to talk about how developer experience kind of relates to productivity. The origin of this 10x myth, or whatever we want to call it, probably started with this study that happened in the late 70s and early 80s called the Coding War Games. So you had these two folks, researchers, Tom DeMarcos, Timothy Lister, and they devised a study that they called the Coding War Games. Basically, about 600 developers from over 92 companies took part in this study, and the purpose was to kind of discover what are the best and some of the worst traits of developers. The competition unit was a pair of programmers from the same organization, but they weren't peer programmers. They were actually competing against each other in the same organization. A program spec was fixed, hey, go write this thing, and the participants logged the time it took for them to complete that task. They used their own workspace and their own familiar tooling and languages, so there's no prescription, hey, you have to use this language or you have to use this framework to do it. Do whatever you're comfortable with in terms of your setting. If you want to learn more about that, we'll probably get these slides out. You'll see a link to it here. There's a big white paper on the study. This would make its way into a book called Peopleware. Really good book, still holds up. I like to, as you'll see me do a couple of times in this talk, draw on what I call the ancient business wisdom of the 70s and 80s. There's actually a lot of really good thought during that time about productivity and how to make work effective. So the best programmers outperform the worst by roughly a 10-to-1 ratio. All right, so again, that's probably where this 10x thing came from. And there were some interesting non-factors. For instance, the language, with the exception of assembly language, didn't actually matter in terms of productivity. So people were doing things in their own language. Number of years of experience. This one's a little hard to hear. But about 2-year developers with about 2 years of experience were performing at roughly the same productivity as those who had 10 or more years of experience, which is pretty interesting. I know, right? Shocking. Yeah. Number of defects. So did these people just write a bunch of crappy code with a bunch of bugs in it to just get it done? No. Actually, there were a number of participants who had completely defect-less code that they wrote for this, and they actually performed slightly better. And then finally, salary. Another difficult one for managers, but the top performers only differed in their salary by about 10%, from the bottom ones. So what did matter? Well, one of the big takeaways from the study is that programmers from the same organization performed at roughly the same level. The average difference was only about 21% between the paired programmers that they were bringing from the organization. And that 21% becomes statistically insignificant when you think about the fact that top was 10x more than bottom. So people working at the same company were performing at roughly the same level, either very well or not so well. They didn't work together on the task, but they came from the same organization, and the best organization actually performed 11 times better than the worst. So Harlan Mills, who was a pretty famous computer scientist working at the University of Florida, said that while this productivity differential among programmers is understandable, there's also a 10-to-1 difference in productivity among software organizations. So basically, the takeaway here is that the best performers are clustering in some organizations, while the worst performers are clustering in others. Those that perform almost as bad as this HDMI is performing. Some companies are doing a lot worse than others. And there's something about the environment and the corporate culture that's failing to attract and keep good people, or making it impossible for even good people to work effectively, okay? Now, the data that came out of this study was very interesting. When they started asking more kind of features of these organizations that were in the top quartile or the bottom quartile, they found out that most of the data, most of the reasoning for these folks performing at the higher level really came down to developer experience, right? So if you look at how much dedicated workspace do you have, those in the top performing quartile had 78 square feet to work in, whereas the bottom quartile only had 46. Is it acceptably quiet, right? Way more people who were in the productive organizations said that it was. Is it private? Can you silence your phone? Even back in the 80s, they had phones. You had to hit a big button to silence it. It was a little bit different. Can you silence it? Yeah. Can you divert your calls? Do people often interrupt you needlessly? So even though the phrase hadn't been coined at this point, the data really said that increased productivity came down to developer experience. And this matters even more now, right? I don't know if any of you have seen the statistic. I think it's staggering. IDC predicted this back in 2020, October of 2020, that 65% of the global GDP would be digitally transformed by now in 2022. That prediction came through. It was accelerated by COVID a little bit, but take that in. 65% of the global GDP is digitally transformed. That is a lot of code. And a lot of organizations aren't even really aligned in the way that they think about productivity. So between Microsoft and the University of Vancouver, there was a joint work that developed this thing called SPACE Framework, right? And SPACE Framework is a nice normalization model for determining how people are thinking about productivity. It does a lot of different things, but it basically breaks down productivity into these 5 categories: satisfaction, performance, activity, communication and collaboration, and efficiency and flow. And the way that this framework can work is that you ask somebody to describe what they think about productivity, and then you literally categorize each sentence that they have in sort of a free-flowing manner of speech into any of these 5 categories. Was that statement about satisfaction? Was that statement about collaboration? Was that statement about efficiency and flow? And in a study back in a newer one now, that was in April of 2022, developers and managers were asked a very similar question. They were asked to answer, when thinking about your work, how do you define productivity? And the managers were asked, when thinking about your team, how do you define productivity? So almost the same question, right? Well, overwhelmingly, the developers made statements that were more related to activity. All right, how many lines of code am I cranking out? How many story points am I dealing with, right? How many modules am I writing, right? It was all about activity. Whereas managers were concerned more with performance. Now, performance being defined by things like, did we meet our deadlines? Did we meet our release dates, right? So a lot of organizations aren't even aligned on their vocabulary around productivity, which can make it very difficult to move forward with things that are actually important, that bring us closer to being 10x organizations. Let's talk briefly about the physics of performance. Again, drawing on the ancient business wisdom of the 70s and 80s. I'm a big fan of Eli Goldratt, Theory of Constraints, and The Goal. Anybody familiar with The Goal? Read that book? All right. What about the Phoenix Project? Anybody checked out the Phoenix Project? Okay, more people, popular book. If you read the intro to the Phoenix Project, they are very clear that they stole their ideas from The Goal. It's pretty much the same idea. You've got a page-turning business fiction drama about a struggling company. They're trying to keep pace with their competitors. A change agent comes in. In the case of the Phoenix Project, they introduce DevOps, and they win and save the business, and it's great. The theory of constraints is central to Eli Goldratt's work. And it's a complicated theory. There's a lot to it. The thing is, Eli Goldratt was not a business person. He was a physicist. And he was one of the first people to make that connection between the laws of physics can actually be used to help make predictions about how a business is going to perform, right? And it gets us in this mode of thinking where instead of considering business cost, we have to think about business throughput, okay? The theory of constraints breaks any complex mechanism or machine down into three basic components. You have inventory, the parts that make this machine work. You have cost, the energy associated with putting those parts together to create throughput, whatever that machine is supposed to do. Now, in the case of a software organization or a software company, cost is organizational cost, right? Inventory is code, and throughput is money, right? So this theory tells us that what we really have to do if we want to positively impact our performance for this company, or for this organization, we have to adopt practices that simultaneously increase the throughput of that business while decreasing cost, right? This is one of the big things where, for instance, layoffs, right? Layoffs help to control cost, but they are actually deleterious to throughput. So believe it or not, layoffs don't fix a business, right? They're only temporarily controlling cost. If you don't have a strategy to also increase the rate at which you're getting, in our case, the code out to market, you're not going to really make a meaningful impact in that business. All right. So we have a practice that we call developer productivity engineering. And I'm going to talk about that a little bit and how it relates to building 10x organizations. And to think about DPE, you've really got to start here, right? These kids look pretty happy. Ecstatic even. And of course they do. They're learning how to code.
No, they just hacked Uber.
Oh, they just hacked Uber. You're right about that.
Yeah.
No, that guy was 17, I think. Close enough, those, you know. But no, they're happy. They just ran maybe systemout.println hello world, and they hit enter, and it popped up on the screen, and it's amazing, and yay, wow, look at this. And you know, coding, for people who really love it, I mean, I think we can all relate to what the creative flow feels like when we're really in our flow state and we're really doing great work.
Who loves writing good code?
Oh, I think we all do, right? Yeah.
Oh, come on.
And the brain has been mapped while developers are writing, actually. They've done these studies, and it's this amazing soup of right brain and left brain activity going on. So no wonder it's so ecstatic, right? On the one hand, we have, you know, creatively thinking about the problem that we're trying to solve, and then we make sort of a hypothesis with the build tool chain. We say, I think this code that I wrote is going to do this thing that's going to help me solve this problem, right? And then we wait for the tool chain to give us that feedback. So now I would ask, what if these kids were waiting 45 seconds, a minute, an hour, some of the most extreme cases we've seen, 20 hours, to get that feedback back from the tool chain? They're not going to look like this. They're going to look like this, and they're probably going to go find some other hobby or something else to do. So I love this quote about creative flow. It isn't about being the best, because once you tap into the creative flow, the best doesn't exist. It's about experiencing the magic. It's about being in that place where your heart is free. It's about grabbing hold of the intangible and making something beautiful, right? So what are we really talking about then in terms of maintaining creative flow for developers? If we can postulate that maintaining that sense of flow is going to lead to better productivity through a better developer experience. What are we really talking about? Well, you can imagine that this is a developer, and they're dealing, like we all do, with feedback cycles, right? They're writing the code, they're click and run, and then they're waiting for the compiler to do its thing, to run its builds, to run its tests, and let them know if they've done the right thing. Sometimes things are fine. This could be a local remote or in a CI environment. Sometimes things are fine. Sometimes they just take too long, right? Sometimes the build or test cycle just takes too long. Sometimes it takes too long to fix, right? Something fails, and we end up spending our time trying to diagnose that failure instead of coding. And then the worst one, the one that really keeps me up, are the problems, the toil, the inefficiencies that could have been avoided altogether if there was just a little bit more proactivity in watching what was happening with the build. So unfortunately, still, in 2022, despite 65% of the global GDP relying on software and these feedback cycles to be efficient, here's how a lot of our calendars still look. We're up, we're fresh, we're coding, we're good, and then we're waiting. We're waiting for a local build to complete. And then it fails. So then we spend the rest of the morning trying to debug that failure. We're playing 20 questions with the build system. We're on Slack. We're trying to figure out what went wrong. We go to lunch. We code. We're happy. We're in our creative flow state again. We come back from lunch. We're waiting for the local build to complete. And it completes this time. Yay, we fixed it. So then we're going to send it to CI and let it build. And then tests are flaky. And the tests that were succeeding in our local environment are failing in CI. And we're going to spend the rest of the day trying to diagnose that. I think we can do a little bit better. DevOps, 12-factor, Agile, all these practices have still not captured all the bottlenecks and friction and obstacles to throughput. And we're numb to it as an industry. A lot of this stuff that we deal with, we just see as an occupational hazard of the job. We interviewed a guy from Netflix who focuses on developer productivity. They have their own developer productivity team, a guy named Danny Thomas. I'll shoot you I think I have a QR code to a blog that we did with him. And he said something in this interview that we had, in this intake. He said, it is staggering the amount of toil and friction and frustration that engineers are willing to put up with, right? Because I think we've just sort of believed that long build times or flaky tests or avoidable failures are just occupational hazards of the job, and we can do better than this. We can wake up from this a little bit. A lot of these bottlenecks are hiding in plain sight in the developer experience itself, and they're out of scope for a lot of the commoditized solutions that are out there around DevOps and Agile. Not that those are wonderful practices. They increase throughput, they decrease cost, and so they're going to be successful, but they've still left some stuff behind right there in the developer experience. Troubleshooting failed builds could involve clunky tools and not great collaboration. A lot of devs are still waiting minutes or even hours for a build and test feedback. So a 10x organization should think about reducing build and test feedback cycle times and improving the consistency and reliability of their builds. So we need to get out of this mindset where we ask the question, okay, is the cycle fast enough? That's the wrong question to ask. The right question to ask is the cycle as fast as it can possibly be, given all acceleration and observation and analytic technologies? Right? We're going to get into some of that now, but that's the essence of developer productivity engineering. Fast feedback cycles are really important, right? I think we don't always consider the cascading impact that they can have to other parts of the organization. On the one hand, of course, there's less idle and wait time. I think we covered that a little bit. That means less context switching for developers, less having to change their focus from writing code to whatever, jumping on Slack and answering emails and stuff while we're waiting for cycles to complete. Well, in the last 10 years, a lot of science has come out. You may have seen this, that humans can't really multitask. Like, we convince ourselves that we can, but it's just an illusion. Our brains can't really do it. But in the last couple of years, we've discovered something even more critical. Not only can we not really multitask, but trying to force our brains to do that is actually bad for our executive functioning. It's actually bad for our brains to try to force multitasking. So you end up with much more focused developers, which has a direct impact on productivity and quality. But also, when you're building more often, when your feedback cycles are faster, you're building your code more often, which means you're refining it more often, right? You're introducing earlier quality checks to the process, which means fewer expensive downstream incidents. You're dealing with smaller chain sets when you actually put your code changes in, which leads to fewer merge conflicts and more efficient troubleshooting overall, and a faster mean time to resolution. Are we going to come back? There we go. So I think probably a lot of people are probably familiar with this cartoon. This is the mindset that we need to get out of, right? I mean, I love Randall Munroe, I love XKCD, but this is not a good excuse anymore, right? You got sword fighting in the hallways. Well, we're working, our code's compiling. No. So it is time for developer productivity engineering. So what's different about DPE versus other ways of managing developer productivity? This practice focuses on taking an engineering approach to productivity, right? So rather than trying to lean on developers to crank out more code, instead it's saying, let's use technology to make build and test cycles faster, and let's use observation and analytics to try to proactively deal with problems that developers would normally have to deal with as part of their toil. Let's use technology to get rid of that. And it follows in the footsteps of a lot of these other practices that I mentioned before are able to increase your throughput while also decreasing your cost. So it's certainly following the same core set of principles that guided more of this ancient business wisdom, just-in-time manufacturing and business process re-engineering, change management, which would become agile and Lean Six Sigma type of practices. Ultimately, of course, DevOps. And now we're going even further left and finding more and more bottlenecks that we're eliminating with the practice of developer productivity engineering, with DPE. It addresses 5 major pain points: waiting for build and test cycles to complete, inefficient debugging of problems, flaky tests, which Spotify kind of famously calls the infinite pit of sorrow for developers, and we'll get into that a little bit. No metrics or KPI observability, right? Very few of us are even tracking the right type of metrics that would define developer experience, and so as we all know, 1,000-year-old adage, if it doesn't get measured, it doesn't get improved. And then this all does have an impact on CI as well. If we're able to make local builds more efficient for developers and we can root that in the build toolchain, then CI systems are going to experience the same thing. They'll become less expensive, they'll become more reliable, we'll have more agents available to do our jobs. And this isn't just our speculation, right? Gradle on the enterprise side is really focusing on developer productivity and this practice of developer productivity engineering. We did our own study. We looked at some of the early adopters of this practice and asked them what were they experiencing before implementing these practices, and overwhelmingly, 90%, too much time spent waiting on build and test feedback either locally or during CI, insufficient observability of analytics on build and test performance and regressions, inability to easily troubleshoot, and managing the growth of build and test cycles as the code base grows. Because ironically, the more successful a software project becomes, the more lines of code, dependencies, and other developers working on that project, the worse the developer experience becomes. The feedback cycle times increase, the amount of bugs increase. So when we talk about the Ironman principle of 10x, we really mean building a powered armor for ourselves using technology. We really mean using engineering to fix this. So that's a lot of theory, but in terms of the tools in practice, for faster build cycles, we recommend looking into build caching. Okay, Gradle and the open source build tool has had build caching built in since 2017. It's not the only tool chain that has build caching available to it. Maven has this now as well. GCC and Clang have the ability to do build caching. For faster test cycles, we recommend test distribution, which is a little bit different than like CI fan-out. We'll talk about that. Predictive test selection, which is pretty new. It's a machine learning-driven approach to test impact analysis that Facebook sort of pioneered in a white paper that they published in 2019, so relatively new. And we'll talk about that a bit as well. Efficient troubleshooting through build scans. Build scans are gathering lots of forensic information about what happened during the build and putting it into a single shareable interface. Now these are available in the Gradle build tool as well as Maven for free, part of the open source tooling. Recommend you look into them and start using them. Failure analytics, right? Just track failures across your development organization. Figure out how many developers are being impacted by those failures so that you can make data-driven decisions about which ones you should be dealing with proactively. And then reliable test through flaky test detection, right? So build caching. Introduced to Java by Gradle in 2017. Steve, is a build cache a dependency cache?
Oh, of course.
It is. It's the same thing. No. So actually, when Steve and I first started working together and thinking about a talk to put together, we both were like, people get our stuff confused a lot. Like, you hear build cache and you think dependency cache. You think like Sonatype Nexus. But they're different things, right? They're very complementary. They're important to one another, right? But they're dealing with different problems. Dependency caches help you with the security of your supply chain and with governance and with managing bandwidth, right? Whereas a build cache is actually there to accelerate a single build, right? It's there to accelerate either Gradle tasks in the case of Gradle, or Maven goals, or Bazel targets, right? And the idea is that we want to be able to pull outputs from the build from a cache if things haven't changed, rather than rerunning that part of the build, all right? So especially in a modular build, right? Most of our build steps are going to create some type of output, right? Compiled classes or test results or something like that. And they're going to have a distinct set of inputs, right? Source code, or the unit test, or the JDK major version, or compiler class path, all these different things. And if the situation is completely identical to a previous run during that build, why rerun that part of the build? We can just pull the output from cache. And if we do this elegantly by generating the way that Gradle works and the way that Maven works is by generating a hash of input from things like source code files and all the inputs to that build, we can do this elegantly to the point where we can distribute this cache, right? So that a Follow the Sun team, for instance, can populate a build cache overnight, and then your first build of the day isn't pull down the new code changes, wait an hour for a clean build, and then actually be able to start your work, right? You can benefit from that remote cache immediately. What about test distribution? So test distribution works by using some type of autoscaler. The agents that we use just run test agents in Kubernetes that are capable of executing JUnit tests and returning feedback back to back to the kind of the central source. It can happen locally, right? So you can schedule these tests to run across distributed agents in parallel from the local machine. And hopefully, you can take advantage of things like elastic autoscaling, like we have in Kubernetes, right? And so this practice is a little bit different from something like a CI fanout, which is what a lot of folks do when they want to try to achieve this sort of parallelism in a test cycle now. They'll manually partition test sets into smaller sets that then turn around and get scheduled in CI to run in parallel. But there's a couple of problems with sort of all of these existing approaches. Build caching is great, but sometimes things do legitimately change, and then we need to rerun those tests kind of no matter what. You can achieve some single machine parallelism using various build systems, including Gradle, but even that's going to be limited by the resources of that one machine. Mac's going to be hovering. And then CI fanout doesn't help during local development. We work with a number of productivity-focused organizations, including Atlassian. We were having a conversation with them a few months ago, and we were speculating, what are some characteristics of a very healthy tool chain? And we said, well, if you can do everything locally, right? I mean, if you've really got the build efficient, and if you've really got the ability to distribute tests, then you shouldn't have to wait on CI to get all of these optimizations. You should be able to do this locally. That led us to a kind of pet campaign that we call Build Local instead of Buy Local. You can find those Gradle t-shirts floating around somewhere. So test distribution allows us to do things locally, and it doesn't rely on CI, and it doesn't rely on manual partitioning, right? So better experience. Here we go. So here's a great example of this. Netflix has implemented both test distribution and build caching. And you can see, it was Danny Thomas, the guy that I mentioned earlier, contributed to this blog. They'll talk about how they reduced one of their back-end Java apps from a 62-minute test cycle time down to less than 5 minutes, just using build caching and test distribution. And can you imagine, what that has done in terms of the way that this team is now able to work on this application? So the blog will kind of take you through, how they achieved that and what the results were. And what about predictive test selection? New form of test impact analysis. Well, how does this one work? Well, you can see the white paper here that was published by Meta, Facebook. They were Facebook at the time. I'm having a hard time calling them Meta. So Facebook published this paper back in 2019, and it's effectively taking a machine learning model to look at a history of changes that have been made to the code base and try to predict what that's going to do to the test set. So instead of running 20,000 tests, most of which are probably just going to succeed, which is like, hey, great, pat on the back, but kind of a waste of time, instead it just says, all right, well, these 50 tests are the only ones that are actually likely to change their status, so only run those, at least pre-merge, right, when you're doing things incrementally. It's a little scary, oh, you're going to skip tests? Not post-merge, you want to run everything, obviously. But pre-merge, you can really get a lot of gains here by using a solution like this. And another cool thing about it is it doesn't require a deep learning model. The white paper describes a gradient-boosted forest, which can run on any old CPU, right? So it's not something that you have to have a crazy cloud GPU rig or whatever to make work. So these things can really be a force multiplier. Sorry that it keeps buzzing out. When used in combination. Build caching can help us avoid running unnecessary tests and steps of the build that have been run in the past. And then predictive can say, okay, if we still have to run stuff, maybe we only really have to run these. And then when we decide, okay, we really have to run this smaller set, let's run them in parallel in an elastically auto-scaling way. Are we? Yeah. Well, I think we're close to wrapping up. Yeah. 10x organizations also track build failures and flaky tests. So do you? I ask this question a lot to big audiences, and the answer is almost overwhelmingly no. Right? I think I asked this question in Jfocus to a crowd of 600 people, something like that. The only people that raised their hands were the Spotify customers who were already our customers. They were using DPE and they were tracking this stuff. So do this though, put common failures on a dashboard and collect impact data so that it's not just one loud, angry developer saying, oh, I've got the worst problem in the world, you need to deal with this immediately. You find out that, oh no, you're really the only one experiencing it and it's probably your fault. Instead, we can say, okay, these failures were experienced by this many developers and they wasted this much time, so let's deal with those first. And the same with flaky tests. In fact, our Gradle Build Tool team and Gradle Enterprise team, they schedule flaky test days, where they open up the dashboard, they start at the top with the flakiest tests that they have in their build tool chain, and they just start proactively working with those and eliminating the flakiness, right? And then what does that do? It prevents altogether developers running into unnecessary failures. 10x organizations also track local build times. Do you? No. But it's the simplest metric for developer experience, right? Just saying how long are developers waiting for builds to complete and putting that up on a dashboard can have a tremendous impact in the way that you think about improving their experience. Because without focus, problems can sneak right back in, right? We accelerate a build once, it doesn't stay fast, right? As we change all kinds of things, like adding a new annotation processor or upgrading our endpoint security, sometimes that build goes from 5 minutes to 8 minutes, and in real life right now, what happens? Nothing. So that sucks, the build took longer this time. Oh well. But we can do something about this if we actually put the data forward. So yeah, most regressions go completely unnoticed, unreported, and not addressed. So to recap, we reviewed kind of the history of productivity thinking and explored the mindset of a 10x developer and organization. And we rooted that mindset in pains and solutions and demonstrated what we call next practices, developer productivity engineering, and introduced some new tooling and some new pains. So if you take a few things away from this, take that most 10x developers aren't born, they're manufactured. Developer productivity is deeply linked to developer experience, and if you do nothing about productivity, life will get worse, right? That's just basic entropy. You have to decrease cost and increase throughput, not one or the other. Fast feedback, efficient troubleshooting, and reliable cycles are key. So start with observation and take action into data. If you take one action from this, start putting this data up on a dashboard. Build a focused team for productivity, like these other organizations have. And check out our book on developer productivity engineering if you'd like. Totally free. You see Gradle logo on the front. That's it. It's a vendor-agnostic practice of developer productivity engineering. I think we're just slightly over, so we'll go ahead and wrap it up.
I have a question. When you were doing distributed testing, what's the way you can collect all the results and feed a dashboard?
So we built special agents that actually run in Docker.
Can you repeat the question?
Oh, I'm sorry. Yeah, the question is how do you get test feedback back from the distributed test agents? And the way that you do that is, in our case, we wrote custom agents that could run JUnit tests, and they report it back to the build system. So the build system actually launches the agent through an API, and then the agent reports its status back to the build tool itself. Yeah, good question. And I know we're over. I want to be.
I mean, we're around all day, so
a
week. No, well, I am. You're going home.
I was supposed to go to DevOps World, but it looks like it's been postponed because of the storm.
Yeah. So I think if you get the idea here, so if you measure something, you can keep track of it, and then you can start affecting it. But if you don't measure how your job works, how your team behaves, you can't improve it. But if you do measure it with using these sorts of tools and others, then you get insight. And if you start saying things like, we won't let this get worse, we'll make it get better, everybody benefits, the whole team benefits. And just by thinking a little bit differently, you really can make a big difference to your productivity. Yeah.
And it's all about data.
Yeah.
So,
cool.
Thanks.
Thank you.
Appreciate it. Enjoy the rest of the show.